Hi, I'm Brian Curry, tutoring high school physics. Today's topic, inclined planes. Here's your typical inclined plane problem. Two weights attached by a pulley, and the question is, in which way does this accelerate, and what's its acceleration? Well, we're going to encounter some very familiar steps. You're going to want to draw your forces, assume acceleration, write the equations, and solve, just like you did with pulleys and friction. So, let's get to work. First off, let's start drawing out our forces. So we're going to start over here, since we're very familiar with this. mg down, using little m because it's the smaller mass. And upwards, we're going to have the force of tension as applied by the rope. Okay, simple enough. Let's move on to the other one. Well, here things are going to get a little tricky, so let me zoom in for you. So here we have our 5 kilogram weight, and there's only one force on it right now, and that's going to be mg down, big M for the larger mass. Well, that's not particularly helpful, because this thing is probably going to be shooting down the incline, but there's no force going down the incline. So here's what we do. Something sneaky known as tilting your axes. So here are our original axes, one x, one y. What we're going to do is we're going to tilt them so that the x-axis lines up with the inclined plane, and our y-axis, well, is perpendicular. So what that actually does is it turns our mg into a hypotenuse. So let me draw our new x, our tilted x and y components. So now you see we have one component that runs down the incline and one that is simply perpendicular. Using this, we can calculate the force that's going to be sending it down the incline, as well as its normal force, because it's the force towards the object in which it's in contact with, and it's perpendicular. Okay, let's actually do that. What is the angle here? Well, this and this are similar triangles, so we take the 30 degrees from this part of the inclined plane and bring it over here. Using this, we can have a bit of trigonometry to solve for what these two legs are. So first, let's find out what mg is. So that's a mass of 5 kilograms times acceleration due to gravity, 10 meters per second squared. So we have 50 newtons due to gravity. This is a 30, 60, 90 triangle, so we can take a few shortcuts. If this is 50 newtons, then the leg opposite the 30 degrees is going to be 25 newtons, and the leg opposite the 60 degree angle, which is going to be over here, is going to be 25 times the square root of 3 newtons. Okay, so now let's draw those forces in out here. We're going to have a component of the force of gravity, which is going to be 25 times the square root of 3 newtons this way. We're going to have the force of tension pulling it backwards this way. And, okay, so there's going to be one more thing, the force of friction. We'll get to that in a minute. Because first, before deciding which direction the force of friction goes, we have to assume an acceleration. So I wrote down, write two equations here. This is going to be important, so let me show you. Let's assume, okay, well, there are two different ways you could assume. We could assume either this, the whole thing is going to accelerate this way, this block is going to pull the thing down, which makes the other direction negative, or this is going to do the pulling, and this is the positive direction. So which one? Let's just assume that the larger weight does most of the pulling. So this is going to be pulling this way, the whole system will go that way, and that's our positive direction. So for here, if upwards is our positive direction, we're going to have our forces equivalent to the force of tension minus mg. For over here, we're going to have forces equivalent to the component of the force of gravity minus the force of tension, and if we're assuming that the whole thing is accelerating this way, minus also the force of friction. But let's just pretend, what if it were going the other way? Let's write out our second set of equations. We have our total force equivalent to mg minus ft, and over here we're going to have our total force is equivalent to, this time the force of tension is going to be the one pulling, minus 25 times the square root of 3 newtons, minus the force of friction. Notice that regardless of which direction the thing is accelerating, the force of friction is always negative. That's because it opposes motion. Okay, well, let's just assume that our first equations are the correct way in which it's accelerating, and let's try to solve them. If we get a negative answer for acceleration, we're going to have to solve our second set of equations and use that answer instead. But let's get to work. So, I'm going to bring this equation down. We get F equals Ft minus mg. Let's actually simplify that. So we're going to call ma equals F sub t minus mg. And over here, let's bring that down. We're going to use the first equation. So ma equals 25 times the square root of 3 newtons minus the force of tension minus the force of friction. Okay, so we need to do something about this force of friction thing here. We know that the force of friction is equivalent to the normal force times the frictional coefficient. The normal force we calculate over here. We see that there are 25 newtons that are being exerted by this object directly perpendicularly onto the plane on which it's located. So that's going to be our normal force, 25 newtons. And I've also given us a frictional coefficient of 0.5 up here. So a force of friction of 12.5 newtons. Now back here, you'll notice if we combine these two equations by adding them, the force of tension disappears. So let's do that. So a bit of addition, we can factor out the acceleration on this side. So the two masses added together, so 5 kilograms and 2 kilograms makes 7 kilograms equals, so the force of tension gets cancelled out. We have 25 times the square root of 3 newtons minus little mass times gravity minus the force of friction is 12.5 newtons. Okay, so let's figure out what the little mass times gravity is. So this stays the same, equals 25 times the square root of 3 newtons. Little mass times gravity, little mass is 2 kilograms times the acceleration due to gravity is 10, so that's 2 times 10 is 20. So that's 20 minus, so 12.5, so that gives us minus 32.5 newtons. So if you put this all together and do the division, you'll actually come up with an acceleration of just barely positive 0.1 meters per second squared. Luckily, this is a positive answer, so this is the correct answer. If it were negative, we'd have to go back and solve the second set of equations. But we're good, and we can keep this answer. It's accelerating at 0.1 meters per second this way. Alright, to recap. When working with inclined planes, draw out the forces on each of your objects. If you have something that's sitting on the inclined plane, take the force of gravity downwards and then tilt your axes. Split it into components such that one component of your force of gravity runs along the inclined plane and the other one is perpendicular to it. Next, assume acceleration. Pick one direction and assume that the entire system is accelerating in that direction. If you have a force of friction involved, also write out the equations for accelerating in the opposite direction. Now actually solve your equations. If you come up with a positive acceleration, go ahead and keep that answer. If you come up with a negative acceleration, solve the other set of equations for accelerating in the opposite direction. Alright, that's all for now. Again, I'm Grant Creer. See you next time.